In this lesson, I'm going to introduce to you the factor theorem. Now, the factor theorem is an extension of the remainder theorem, which is what I taught in the last lesson. So, benefits of the factor theorem is that it can be used to factor high degree polynomials. So let's get started with the actual theorem here. If P of A is equal to 0, then x minus A is a factor of P of x. That means if this is equal to 0, meaning if the remainder is equal to 0, then this binomial is a factor of this polynomial. It also means that this binomial divides evenly into this polynomial. So let's start with the first example here. My question is, determine if x minus 1 is a factor of P of x. So to determine if this binomial is a factor, we use the factor theorem. So start with the potential factor. In this case, it's x minus 1 is equal to x minus 1, and we're going to equate it to 0. Therefore, the root is equal to 1. Now, if this is a factor, we want to prove that P of 1 is equal to 0. So check if that's true or false. So go back to your polynomial. Wherever you see an x, you're going to plug in a 1. So 2 times 1 cubed minus 4 1 squared plus 3 times 1 minus 1 could or could not be equal to 0. We'll have to check. So 2 times 1 cubed gives me a 2. This is a 4. 3 times 1 gives me a positive 3 minus 1, and this is equal to 0. Let's keep going. 2 minus 4 gives me a negative 2. 3 minus 1 gives you a positive 2. And that's equal to 0. Negative 2 plus 2 is a 0. So we have proven that left-hand side is equal to right-hand side, and this is a true statement. That means we have just shown that this binomial x minus 1 is a factor of this polynomial. So my answer is yes. Okay, next slide. If P of x is equal to this monster here, what is the value of k such that x minus 8 is a factor of P of x? So we are given one piece of key information here. This binomial x minus 8 is a factor of P of x, which means, let's find the root. X minus 8 is equal to 0. That means the root is equal to 8. It means P of 8 is equal to 0. The remainder is equal to 0 because it's a factor. Okay, so using this relationship right here, we're going to find the value of k. So go back to this polynomial up here. Wherever you see an x, you're going to plug in an 8. So 8 to the power 4 minus 8 to the power 3 plus k, which is what we want to find, 8 squared, minus 8, weird looking 8. I'm going to erase that. I'm not happy. And that's better. Plus 8 is equal to 0. Okay, so let's do some simplification here. 8 to the power 4 is a rather large number, 4,096. 96, there you go. Minus 8 cubed, which is a 512, plus 8 squared times k, which I'll write as 64k, because to me that's more visually pleasing. And take a look here, we have a negative 8 plus an 8. Now you can recognize right away that that is a 0, so I'm not going to bother writing that down. And finally, this is equal to 0. Let's simplify even further here. If we combine these two like terms, we get a value of 3,584. Plus is 64k, and this is equal to 0. Okay, so next step would be to subtract 3,584 from both sides. And I'm left with 64k on the left-hand side and negative 3,584 on the right-hand side. Last step, I see the finish line here. We want to divide both sides by 64. And once we do that, these cancel out, and I'm left with a k value of negative 56. So that is my little introduction of the factor theorem.